Dear students, Namaste and welcome back to a new mathematics session. In the previous session, we have discussed question number 1 to 29 from exercise 13.1. Hope it was clear for you all. In today's session, we shall discuss the remaining problems from exercise 13.1 and also will discuss the concept of derivatives. Let's move on to the topic. Now let's begin with question number 30. If f of x is equal to mod x plus 1 if x less than 0 and f of x is equal to 0 if x is equal to 0 and if f of x is equal to mod x minus 1 x greater than 0. For what value or values of a does limit extends to a f of x exist? So there is a function given to us. We are asked to find out the value or values of a in which limit extends to a f of x exists. As we know that limit extends to a f of x exists means the left hand limit and the right hand limit means limit extends to a minus and limit extends to a plus should coincide, means they should be equal. Then we can say that limit extends to a f of x exists. And here there is mod x is there in the first category and in the third function also. So we can just define this mod x for easy calculation. That is f of x is equal to, here x is less than 0. When x is less than 0, mod x is equal to minus x. So this mod x we have replaced and put as minus x. So minus x plus 1 if x less than 0. Then second values remain same, f of x equal to 0 when x is equal to 0. And here x is greater than 0. When x is greater than 0, mod x value is plus x. So x minus 1, mod x is removed and substituted x. So x minus 1 if x greater than 0. So simply we have defined or we have rearranged this mod x based on their definition of modulus function. We have already discussed this one in the previous classes, how this modulus values changes. So now our new function is f of x is equal to minus x plus 1 if x less than 0 and if f of x is equal to 0 if x is equal to 0 and f of x is equal to x minus 1 if x greater than 0. Now we are asked to find out the values of a, means here clearly there are three cases are there, means the three cases which comes are when a is equal to 0 and less than 0 and greater than 0. So 0, greater than 0 and less than 0 are the three cases we are going to consider. And the first case when a is equal to 0. When a is equal to 0, limit extends to 0 minus f of x is equal to, see this is the function we are going to check. Okay, so limit extends to 0 minus f of x means negative side of 0. So negative side of 0 means this function we are going to take minus x plus 1. That is limit extends to 0 minus x plus 1. Directly we can substitute 0, that is 0 plus 1, that is equal to 1. And next is limit extends to 0 plus f of x, that is equal to limit extends to 0 plus, here positive value means x greater than 0, that is x minus 1 function we are going to take. Limit extends to 0, x minus 1. Then when we substitute here limit extends to 0, x can be replaced and put as 0, that is 0 minus 1, that is equal to minus 1. So here clearly visible, one is left side is 1, right side is minus 1. Left hand limit is 1, right hand limit is minus 1. They are not coinciding, means they are not equal. So limit extends to 0, f of x does not exist. So the first case it is clear, here limit does not exist. Then the second case is when a less than 0. Here onwards a little bit of concentration you need to give. When a less than 0 means this is the function we are going to use throughout. When a less than 0 means x less than 0 means a single function we are going to take, that is minus x plus 1. For left hand limit also and the right hand limit also, this is the function we are going to take, because here a less than 0 means the condition is clear. X less than 0 means this is the function we are going to take, that is limit extends to a minus f of x. A minus f of x means here main condition is a less than 0. A less than 0 means this is the function we are going to take, minus x plus 1, that is equal to limit extends to a minus x plus 1. Directly we can replace, that is equal to minus a plus 1. X can be replaced by a, that is minus a plus 1. Then limit extends to a plus, the right hand limit of f of x is equal to, as I mentioned before, since a less than 0, this is the function minus x plus 1. So limit extends to a minus x plus 1. Here also just when we substitute it comes as minus a plus 1. So here you can see on the left hand side and the right hand limit both are equal. So limit extends to a minus f of x is equal to limit extends to a plus f of x is equal to minus a plus 1. So both limit are coinciding, therefore we can say that the limit exists for a less than 0. Next is case 3, that is when a greater than 0. Here when a greater than 0 means this is the function we are going to take throughout, that is x minus 1. Remember when a less than 0 means we have taken for both left hand limit and right hand limit, this is the function we have taken, and when a greater than 0 means this is the function we are going to take. That is limit extends to a minus f of x is equal to limit extends to a x minus 1 that we have taken. Then we can replace x as a, that is a minus 1. Then right hand limit, when you take limit extends to a plus f of x is equal to, same way this is the function because a greater than 0. So this is the function x minus 1. Limit extends to a x minus 1. Then when you substitute x as a, there is a minus 1. And here also left hand limit and right hand limit both are coinciding. So limit extends to a minus f of x is equal to limit extends to a plus f of x is equal to a minus 1. So limit exists for a greater than 0. Therefore, we can say that limit extends to a f of x exists for all a where a not equal to 0. Means here a equal to 0 means the limit does not exist. It means this is the condition we are writing for left hand limit a less than 0 and as well as for a greater than 0 also limit exists. But for the case of a equal to 0 it is not existing. So we have to conclude like limit extends to a f of x exists for all a where a not equal to 0. If a equal to 0 means limit does not exist. So that's why we are concluding as where a not equal to 0. Next, we shall discuss question number 31. If the function f of x satisfies limit extends to 1 f of x minus 2 by x square minus 1 is equal to pi, evaluate limit extends to 1 f of x. So here this is a condition given to us and we are asked to find out x tends to 1 f of x. So let's take the given condition. Limit extends to 1 f of x minus 2 by x square minus 1 is equal to pi. Here by using algebra of limits, we can split the limits in numerator and denominator. That is limit extends to 1 f of x minus 2 divided by limit extends to 1 x square minus 1 equal to pi. We can take this limit here. That is limit extends to 1 f of x minus 2 is equal to pi into this quantity. So pi into limit extends to 1 x square minus 1. Then limit extends to 1 f of x minus 2 is equal to, you can check here, this 1 can be substituted here, that is x can be replaced and put the value 1. So pi into 1 square minus 1. 1 square minus 1 is 0. So pi into 0 is 0. So right side completely 0. That is limit extends to 1 f of x minus 2 is equal to 0. Again we can use the algebra of limits here. That is limit extends to 1 f of x minus limit extends to 1 2 is equal to 0. That is equal to limit extends to 1 f of x minus 2. This is the constant. So limit extends to 1 2 is 2 itself. Limit extends to 1 f of x minus 2 is equal to 0. Then we can take this minus 2 to right side. That is limit extends to 1 f of x is equal to 2. That is what we have to calculate. Limit extends to 1 f of x value that we have got as 2. Move on to question number 32. If f of x is equal to mx square plus n, if x less than 0, f of x is equal to nx plus m, if 0 less than or equal to x less than or equal to 1, f of x is equal to nx cube plus m if x greater than 1. Question: for what integers m and n does x tends to 0 f of x and limit extends to 1 f of x exists? So here for what integers m and n values we have to calculate. Does f limit extends to 0 f of x and limit extends to 1 f of x exists? Here as we know that limit extends to 0 f of x exists, in the sense we need to find out the left hand limit and right hand limit both should coincide. Then we can say that limit exists in that particular point, that is limit extends to 0. First of all, left hand limit, if you check, limit extends to 0 minus f of x, that is equal to limit extends to 0. 0 minus means less than 0. This is the function mx square plus n. So limit x tends to 0 mx square plus n. We substitute as x is equal to 0, m into 0 square plus n, that is equal to n. We have got m into 0 plus n, that is n. Then we will go with the right hand limit. Limit x tends to 0 plus f of x. 0 plus means we'll be taking the function as nx plus m because it is between 0 and 1. Limit x tends to 0 plus just after 0. Just after 0, very close to 0 but not equal to 0. That is what x tends to 0 plus means. So the function will, the domain will be here. 0 less than or equal to x less than or equal to 1. The function will be nx plus m that we have taken. So limit x tends to 0 nx plus m. Then when we put the value here, n into 0 plus m, that is n into 0 is 0 plus m. So we have got as m. Then if limit x tends to 0 f of x exists, means this left hand limit and right hand limit should coincide, means they should be equal. M and n should be equal. So limit x tends to 0 f of x exists if m is equal to n. This is what the first question answer. Then second one is limit x tends to 1 f of x. As before, we have to go with the left hand limit. Limit x tends to 1 minus f of x is equal to 1 minus, in the sense here we have to go with the left hand side of 1. Left of 1 means here 0 less than or equal to x less than or equal to 1. 0 to 1 is the domain, just including 0 and 1. Including 0 and 1, between 0 and 1 is the domain here. Here 1 minus, in the sense just before 1. Just before 1 but not equal to 1. So just before 1 means it comes here. So the function will be nx plus m. So limit x tends to 1 nx plus m. Substitute the value of x as 1. So n into 1 plus m, that is equal to m plus n if you are arranging in alphabetic order. Then limit x tends to 1 plus f of x. 1 plus f of x means just after 1 but not 1. So limit x tends to 1 plus f of x is equal to limit x tends to 1 just after 1. Just after 1 means this one, x greater than 1. X greater than 1 is the domain. Then the function will be nx cube plus m. So limit x tends to 1 nx cube plus m. Then substitute the value n into x cube means 1 cube. N into 1 cube plus m. N into 1 cube plus m means n plus m. If you arrange it in order, m plus n. So here limit x tends to f of s exists if m plus n is equal to m plus n. Means left hand limit is m plus n, right hand limit also m plus n. Means this is always true for whatever value of m and n. If you substitute on the left hand side and right hand side, this statement will be true. That means limit x tends to f of x exists at all integral values of m and n. All integral values of m and n, whatever values if you put m and for m and n, left hand side and right hand side will satisfy. So limit x tends to 1 f of x exists at all integral values of m and n. That is the way we can go for the conclusion. Next we shall discuss the concept of derivatives. In the earlier classes we have learned how to find out the slope of a straight line when 2 points are given to you. For example, consider the axes x and y, and if you have considered a straight line and by taking 2 points x1 y1 and x2 y2, the slope of this straight line can be calculated by using the formula slope is equal to y2 minus y1 divided by x2 minus x1. Means change in y divided by change in x, that is slope is equal to delta y divided by delta x. Delta means the representation of change in y divided by change in x. Diagrammatically, if you represent, this is a straight line on the coordinate plane, that means on the x and y axis, and the change in x is here and change in y is here. So change in y divided by change in x is the formula for finding the slope of a straight line when 2 points are given to you. Again, we can find an average slope between 2 points. For example, consider a curve. Previously we have taken a straight line. Here we are considering a curve, and in this curve we are taking 2 points, here 1 point and here another point, and by joining this point we will get a straight line. And when we get a straight line, again like the previous one, we can calculate the change in x and the change in y. Here change in x is 15 units for example, and change in y is 24 units. Means average slope is equal to 24 divided by 15, means change in y divided by change in x. Means in these two cases we have calculated the slope when 2 points are given to you. Means for calculating the slope in normal case we need 2 points, because then only we will be able to calculate y2 minus y1 by x2 minus x1. That means change in y divided by change in x. But how do we find the slope at a point? Means when one point is given to you, how do we calculate the slope? That is what we are going to discuss. For example, consider the same slope, and if it is given, if we have taken a point, a particular point, and how do we find out the slope at this point? Means by using this formula, change in y. Of course, there is only one point, there is no change, so the change in y is 0 here, and the change in x also 0, because we are calculating or we are considering only one point. Means by using the previous formula we can calculate slope is equal to 0 by 0, means it is indeterminate form. So next we are going to discuss how we will calculate the slope of a given point by using the concept of limits. Here again we are going to discuss how to find out the slope at a given point. The slope of the tangent line at a point on the function is equal to the derivative of the function at the same point. Here previously we are considering a curve and we are taking a particular point, and as we know that the tangent means it is a straight line touching a given curve at a particular point. Here, to find the derivative of a function y is equal to f of x, we use the slope formula. Here we begin with the concept of derivatives. Means this is a very important concept in calculus. So here considering a curve and a particular point, and what we are going to discuss is how to find out the slope at this point by using the limit formula, or the concept of limit. Just we are considering a very close point. Here of course it is only one point is visible, but we are just considering one more point just after this point, means very close to this point. When we zoom it, the point may look like this, and this is a curve, and here one point, and just after that point we are considering another one point that is very close to the first point, and by connecting these 2 points we can draw a straight line. And now we will be getting the delta x and delta y, means change in x and change in y will be getting, but change in x and change in y are very small values, because these 2 points are very close to each other. And slope is equal to change in y divided by change in x, as we know the formula. Here x changes from x to x plus delta x. First, when we consider this point, maybe this point we can consider as x comma y, and we are just considering one point just after, very close to this point, means very small change it is making, that we can consider as x changes from x to x plus delta x, just a small value. Delta x means a very small change in x, very small change in x. That means the next point will be x plus delta x. Same way y changes from f of x to f of x plus delta x. Here f of x is a function represented by the symbol y, so y can be written as f of x, and f of x is changing from f of x to f of x plus delta x, a very small change. That is what this delta x represents. So this is what the values looks like, and here we have taken a point, and very close to that particular point we are taking another point, and here delta x is the change in x and delta y is the change in y. Means delta y in the sense, first it was f of x and that is y value or y function, and after taking the next point it is changes from f of x to very small change, that is delta x, it is changing f of x plus delta x. That is what this point. So here when we substitute in these values in the formula of slope, change in y in the sense f of x plus delta x is one value and another value is f of x, like y2 minus y1. So f of x plus delta x minus f of x, so we will get the difference in y values here, divided by change in x. Change in x is, here we know that it is a very small value is changed of for x, that is delta x we are considering. So f of x plus delta x minus f of x divided by delta x. Suppose f is a real valued function and a is a point in its domain of definition. The derivative of f at a is defined by limit h tends to 0 f of a plus h minus f of a divided by h. Here h tends to 0. As per the definition of limit, h is not equal to 0 but h is very close to 0. And here f of a plus h minus f of a means there is a very small change. F of a plus h minus f of a divided by h. And as we know, h tends to 0 means h is not equal to 0 but h is very close to 0. The definition is limit h tends to 0 f of a plus h minus f of a divided by h. This is if f is a real valued function and a is a point in its domain. By definition, the derivative of f at a particular point a, that is limit h tends to 0 f of a plus h minus f of a by h, provided this limit exists. We know the condition in the previous classes we have discussed. Limit exists means left hand limit and the right hand limit should coincide. Derivative of f of x at a is denoted by f dash of a. Derivative is represented with a symbol that is dash, f dash of a, because a is the given point. The derivative of f at a is denoted by f dash a. Next, we will discuss a very important concept of derivatives, that is first principle of derivative. Suppose f is a real valued function. The function defined by limit h tends to 0 f of x plus h minus f of x divided by h. Here, wherever the limit x is defined to be the derivative of f at x and is denoted by f dash x. So the derivative of f at x is denoted by f dash x, and this definition of derivative is called the first principle of derivative. The derivative of f at x. Previously we have learned derivative of f at a. There we have learned f of a plus h minus f of a divided by h. Here derivative of f at x, that is limit h tends to 0 f of x plus h minus f of x divided by h. This is the first principle of derivative, and this can be represented by f dash x, means the derivative of x at the derivative of f at x, that is f dash x, is equal to limit h tends to 0 f of x plus h minus f of x by h. This also can be written as d by dx of f of x. This f dash x, or the derivative of x, can be represented by d by dx of f of x. D by dx of f of x is equal to the same definition, limit h tends to 0 f of x plus h minus f of x by h. Again, one more way we can represent this one, that is if y is equal to f of x. If f of x is represented by using the letter y, then this derivative can be written as dy by dx. Dy by dx. This is the symbol, or this is the way we use in common calculations, dy by dx. Next, we shall discuss some algebra of derivatives and also some important definitions or rules of derivatives. The first one, d by dx of f of x plus g of x is equal to d by dx of f of x plus d by dx of g of x. Next one, d by dx of f of x minus g of x is equal to d by dx of f of x minus d by dx of g of x. Derivative of product of two functions is given by the following, the product rule. This is called the product rule, that is d by dx of f of x into g of x, that is equal to d by dx of f of x into g of x, means the derivative of the first function into the second function plus first function into the derivative of the second one. So very carefully you have to learn this one. Means d by dx of f of x into g of x is equal to derivative of the first function into the second function alone, not derivative, plus first function into derivative of the second one, d by dx of f of x into g of x plus f of x into d by dx of g of x. Derivative of quotient of two functions is given by the following quotient rule, wherever the denominator is non-zero. So d by dx of f of x by g of x is equal to First of all, in the denominator we have to write this denominator square, that is g of x the whole square. Then in the numerator, derivative of the first function into the second function, that is d by dx of f of x into g of x minus first function into derivative of the second. Once again, first of all we have to write the denominator square, then derivative of the numerator into the denominator minus numerator into derivative of the denominator. So little more shorter way we can write this one. Let u is equal to f of x and v is equal to g of x. This f of x and g of x we can represent by using u and v. Then its derivatives can be represented by u dash and v dash. So the product rule is uv the whole dash, means the derivative of uv the whole dash is equal to derivative of the first function into the second function, that is u dash into v plus u into v dash, means the first function into the derivative of second. And this is called Leibniz rule of differentiating product of functions. So this name you have to keep in mind. Then the quotient rule will be changed as u by v the whole dash, means the derivative of u by v is equal to denominator square, that is v square, into u dash v. That means the derivative of first one, that is the numerator, into the denominator minus here u into v dash. U into v dash means the numerator into the derivative of the second one, means the denominator. Once again, u by v the whole dash is equal to denominator square, that is v square, then u dash v. U dash means derivative of the numerator into the denominator minus u into v dash, means numerator into derivative of the denominator. This is what the quotient rule. Next we shall discuss the exercise questions. Exercise 13.1. First question. Find the derivative of x square minus 2 at x is equal to 10. Here we are asked to find out the derivative of this function at a particular point, that is x is equal to 10. So let f of x is equal to x square minus 2. Let us consider this function as f of x. F of x is equal to x square minus 2. Let's recall the formula what we have learned. Derivative of a function at a point a, that is limit h tends to 0, f of a plus h minus f of a divided by h. Here f dash 10, that is what we are going to calculate. F dash 10 is equal to limit h tends to 0. It's the same formula we are going to use. Limit h tends to 0, f of 10 plus h. 10 plus h means something which is very close to 0, very small value, but not equal to 0. F of 10 plus h minus f of 10 means f of a plus h minus f of a. Here a is 10. So f of 10 plus h minus f of 10 divided by h. Now limit h tends to 0, f of 10 plus h. Here instead of x we have to put 10. So 10 plus h the whole square minus 2 minus f of 10. F of 10 means instead of x here 10 we have to put 10 square minus 2 divided by h. That is limit h tends to 0, a plus b the whole square form, a square plus 2ab plus b square. Here a square is 10 square plus 2ab, 2 into 10 into h, plus b square is h square minus 2, no change. Here minus, here remove the bracket, that is minus into 10 square minus 10 square, minus into minus plus 2 divided by h. Only the numerator we have done the calculation. Then limit h tends to 0, here plus 10 square minus 10 square can be cancelled. Then 2 into 10 into h, that is 20h, that is written here. Then plus h square, and here there is a minus 2 and plus 2, that also can be cancelled. So plus 10 square minus 10 square cancelled, minus 2 plus 2 can be cancelled. The balance we have written here 20h plus h square divided by h. That is limit h tends to 0. You can take a h common from numerator, that is 20h plus h square. There is a h common. If you take h common and cancel with the denominator, the numerator we will be having balance only 20 plus h. That step I have not included here. If you want, you can do it. You can calculate or you can return here. It's not a problem. 20 plus h square. From h square, h is cancelled. So we will be getting the value as 20 plus h. We have taken a h from the numerator and cancelled with the denominator. Balance term is only 20 plus h. That is what it is written here. Now we can easily substitute the value of h here. That is limit h tends to 0, 20 plus h, that is equal to h can be replaced with 20, sorry, h can be replaced with 0, this 0. So 20 plus 0, that is equal to 20. So limit here, limit x tends to, sorry, limit h tends to 0, f of 10 plus h minus f of 10 divided by h. We have calculated, and finally we have got the answer as 20. So the required answer is 20. The derivative of x square minus 2 at x is equal to 10 is 20. The final statement we have to write. Next is question number 2. Find the derivative of 99x at x is equal to 10. Here again, as before, f dash of 100 we have to calculate. This one we can consider as f of x. So f dash of 100 is equal to limit h tends to 0, f of, instead of a 100 we have to put 100 plus h minus f of 100 by h. Then limit h tends to 0. Here 99 into x is the function. So 99 into function x can be replaced with 10 plus h. That is 99 into 10 plus h minus f of 100 means x can be replaced with 100. 99 into 100 divided by h. Denominator is same. Limit h tends to 0. Remove the bracket. 99 into 100 plus 99 into h minus 99 into 100. And here again plus 99 into 100 minus 99 into 100 we can cancel. So limit h tends to 0, 99h divided by h. Here also h and h can be cancelled. So limit h tends to 0, 99 will be getting. It is a constant. So directly we can write the answer. Limit h tends to 0, 99 is equal to 99. So the final statement we can write, the derivative of 99 at x, 99x at x is equal to 100 is 99. Move on to question number 3. Find the derivative of x at x is equal to 1. Just like the previous questions, we can calculate this one, like f of x is equal to x we can consider, and then by using the formula of derivative of a function at a point a, by using that definition we can calculate this value. So this one you will do it as homework. Question number 4. Find the derivative of the following functions from the first principle. By using first principle, we have discussed already what is first principle. By using first principle, we are asked to calculate the derivatives. There are 4 questions. X cube minus 27, x minus 1 into x minus 2, 1 by x square, x plus 1 by x minus 1. So let's discuss the first question. Let f of x is equal to x cube minus 27. The given function we are taking as f of x. F of x is equal to x cube minus 27. By using the first principle, we have already discussed the first principle, that is f dash x is equal to limit h tends to 0, f of x plus h minus f of x by h. In the previous question we have discussed as f of a plus h, but here it is limit h tends to 0, f of x plus h minus f of x by h. Let's find out limit h tends to 0, f of x plus h. Here instead of x we have to put x plus h, that is x plus h the whole cube minus 27. That is what the first value. Instead of x we have substituted x plus h. So x plus h the whole cube minus 27. That is what here. Minus f of x. F of x we know that is x cube minus 27. Here when we observe there is a minus 27 and here minus into minus plus 27. These two can be cancelled. These two 27s will be gone. So limit h tends to 0. This we can expand by using the formula a plus b the whole cube. So a plus b the whole cube, we know the formula a cube plus b cube plus 3a square b plus 3ab square. If you want you can write down on the right side, or else you can write it from the memory. It's not a problem. A plus b the whole cube is equal to a cube plus b cube plus 3a square b plus 3ab square. Once again I repeat, a plus b the whole cube is equal to a cube plus b cube plus 3a square b plus 3ab square. By using that we can remove this bracket. A cube, that is x cube, plus b cube, that is h cube, 3a square b, that is 3 into x square into h. It's written here. 3ab square, that is 3 into x into h square. It is written here. And here there is only one term balance, that is minus x cube. And here also when you check, there is a plus x cube, there is a minus x cube. We can cancel these two. Then the balance will be coming as limit h tends to 0, h cube plus 3x square h plus 3xh square. Here x cube and x cube is gone. Divided by h. That is limit h tends to 0. From here you can take h common. When you take h common, we'll be getting balance as h square plus 3x square plus 3xh. From here 1h we have taken out, the balance only we have discussed. So h into h square plus 3x square plus 3xh divided by h, and this h and this h can be cancelled. Here cancellation I am not showing because it is easy to do, that's why it's not showing. Whenever it is difficult, that will be shown in the video. That is, limit h tends to 0, the balance h square plus 3x square plus 3xh. Then we can just put the value h is equal to 0, that is here 0 square plus 3 into, here there is no h, so no substitution, that is 3x square plus 3xh. Here there is h, so replace and put 0, so 3x into 0. Here 0, here also 0. So we will be getting only 0 plus 3x square plus 0. Finally, we will be getting the answer as 3x square. So the derivative of the function x cube minus 27 by using the first principle is 3x square. That is f dash x, derivative of x, we can represent it by using f dash x. F dash x is equal to 3x square. Next we shall discuss the second part, that is x minus 1 into x minus 2. We have to find out this derivative by using the first principle, that is let f of x is equal to x minus 1 into x minus 2. We have considered this one as function f of x. Then by using the first principle, f dash x is equal to limit h tends to 0, f of x plus h minus f of x divided by h. Let's find out f of x plus h. Simply replace this x and put x plus h, that is f dash x is equal to limit h tends to 0, f of x plus h. Here x replace and put x plus h, that is x plus h minus 1, it is written here, into x plus h minus 2, it's written here, minus f of x. F of x is this one, same function, x minus 1 into x minus 2 divided by h. Now only calculations are left, that is limit h tends to 0. Here remove the bracket, x into x, that is x square, x into h, that is hx, x into minus 2, that is minus 2x, h into x, that is hx, h into h, that is h square, h into minus 2, that is minus 2h, minus 1 into x, that is minus x, minus 1 into h, that is minus h, minus 1 into minus 2, that is plus 2. Here also we have to remove, outside minus just to keep. Then x into x, that is x square, x into minus 2, that is minus 2x, minus 1 into x, that is minus 1x, then minus into minus plus 1 into 2 is 2. Then we'll go for cancellation. X square and x square can be cancelled, and minus 2x and here minus 2x means this minus, when it comes inside it becomes plus 2x, so minus into minus plus, so this minus 2x and this minus 2x can be cancelled. And if you feel confused this portion, you can just remove this bracket and go for cancellation, that is up to you. Then here there is a minus x and there is again minus into minus plus x here, this minus into this minus, that is plus x, that can be cancelled. And here there is a plus 2 and here there is minus into plus minus, so minus 2, plus 2 and minus 2, this also can be cancelled, divided by h. So the balance we can pick and write, limit h tends to 0, here there is a hx is written, here there is one more hx, that is also written, plus h square, it's here, minus 2h, that is here, then this plus 2 cancelled, and there is one more term, that is minus h, that is the balance, it is written here, divided by h. That is limit h tends to 0, hx plus hx is 2hx, then h square minus 2h minus h, that is minus 3h divided by h. Then we can cancel by taking a common h in the numerator, and the denominator h can be cancelled, that is limit h tends to 0. If you remove h from the numerator, 2x balance, here there is h balance, here there is minus 3 balance, and that a common h you have cancelled with the denominator. Then 2x plus h minus 3 is the balance term. Again here also the same thing, cancellation is not shown. If you feel difficulty, you can write that step. Then you can substitute as h is equal to 0. That means here 2x plus this h will be 0. 2x plus 0 minus 3. So 2x minus 3 is the answer, is the derivative. Then next one, question number 3, f of x is equal to 1 by x square. So we have considered the function as f of x. Then by using first principle, f dash x is equal to limit h tends to 0, f of x plus h minus f of x by h we have written. the first principle. Then as before, we will go with the f of x plus h. Here there is 1 by x square, so we have to be careful because the variable is in the denominator. So f dash x is equal to limit h tends to 0, f of x plus h. So this x can be replaced by x plus h. So 1 by x plus h the whole square minus again f of x. F of x is 1 by x square itself. It's written here divided by h. Now for easy calculation purpose, this h we can bring on the corner, that is limit h tends to 0. This h we can bring this side, means just keep it aside, that is 1 by h into. Now these two terms we can take and go for the calculation. Here common LCM we can take it as x square into x plus h the whole square, and 1 into x square, that is x square, minus 1 into x plus h the whole square, that is minus of x plus h the whole square. Let's remove the bracket in the numerator, that is limit h tends to 0, 1 by h into x square. Here a plus b the whole square, a plus b the whole square formula is a square plus 2ab plus b square. A square in the sense here x is there, so x square. I am removing the bracket also the same time, expansion plus removing the bracket. So here a square, that is x square, there is a minus term outside, so minus x square will be coming. 2ab, that is 2 into x into h, that is 2hx. There is a minus outside, so minus 2hx. Then third term is b square, that is here h is b, h square. H square, there is a term minus term outside, so minus h square divided by x square into x plus h the whole square. Here also single term is cancellation is there, x square can be cancelled. That is limit h tends to 0, 1 by h into balance is minus 2hx minus h square divided by x square plus h the whole square. That is limit h tends to 0. Here you can see there in the numerator there is an h square is common. Here just we have minus 2hx is first, second is minus h square. Just I have arranged in degree order, higher degree is first. If you are not arranging also no problem, minus h square minus 2hx. In these two there is a h common, and here there is a denominator we kept one more h from the question. So these two h's can be cancelled. That means there is no denominator h, and from the numerator one h will be gone. So balance is minus h, and here one h going means minus 2x divided by denominator is same, a square into x plus h the whole square. Here now you can put h as 0, that is here h0 means 0 minus 2x divided by x square plus x plus h is 0, 0 the whole square. So 0 minus 2x is minus 2x, then x square into x square. So x square into x square is x raised to 4. So minus 2x by x raised to 4 is there. In that case, that x raised to 4 in the denominator and 1x in the numerator can be cancelled. So numerator x is gone, denominator x 1 will be reduced. Here denominator x power 4 is there. X square into x square. X power 4 is there. So from that 4, 1x cancelled. So balance in the denominator is x cube. And in numerator there is no x, that is minus 2 by x cube. There are several calculations I have removed just to keep the answer in the one single slide. So if you are feeling difficulty, then you can include that step. I have included that portion in the explanation. So if you feel it is difficult, then you can write down that step, especially these portions and all. Here how x is cancelled. So the final answer is minus 2 by x cube. Next is the fourth option, f of x is equal to x plus 1 divided by x minus 1. So we have considered this function as f of x, and by using the first principle you can find out the derivative, and this question you will do it as homework. Dear students, today we have discussed the concept of derivatives and we have solved questions by using the first principle. I request all the students to go through these questions, and while practicing, if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.